So last class we discussed about the Oersted experiments and Oersted observations, and also the Ampere swimming rule, and also the snow rule. So this thing we understood in the last class. So now we will discuss about the right hand screw rule or Ampere's corkscrew rule to determine the direction of the magnetic field, and also the right hand thumb rule. So what is the meaning of the right hand screw rule is, suppose you have to draw a screw here. So this is a screw. There is a screw here. Now you can see the screw can rotate in this direction, and here is a cork is placed. So I current is going in this direction. I current is going, and the screw is placed. Imagine the screw is placed on the wire, and it is going inside the cork. As it is going, so that means only you have to tighten the screw. So that means the magnetic field will be in this direction. Okay. So remember, magnetic field is a vector quantity. So this is your cork. This one, the screw. And next one is very easy one. So that one is a right hand thumb rule. So for that you have to draw your thumb this way. This is your thumb. This is your finger. This is your right hand. And suppose that imagine that you are holding the current carrying conductor in such a way that I current is going in the upward direction. Your thumb will be in the direction of the current. So the magnetic field, the direction of the magnetic field will be along your finger in this way. And this way, this is the magnetic field. I'll draw one more line. So this is the magnetic field. Think this is a conductor. As the conductor is carrying current in this direction from here to here. Now I want to find out the magnetic field. Then I have to hold this thing in this way. In this way. Current is going in upward direction. My finger will be in this way. So I try to hold in this direction. So magnetic field will be in this, around this, like this way. The magnetic field will be produced. So normally, if I draw a plain paper, if I draw a conductor, current is going in this direction, then if you use your right hand rule in this direction, so obviously the magnetic field is coming out from the paper and going inside the paper. See, my finger is coming out from the paper and going inside the paper. As the vector is coming out, so you can write with a dot, and the vector is going inside the paper, then you can write with a cross. So this is the magnetic field is coming in this way. You have to think in a three-dimensional way so that you can understand. This is the magnetic field is coming out from here, and here the magnetic field is going out. So magnetic field is in the back side of the paper also. The magnetic field also going in the same way. So this is the right hand rule. So I will tell the rule one more time. If a conductor carrying current is imagined to be held in the right hand such that the thumb points in the direction of the current, then the tip of the curled fingers, this is the tip of the curled fingers, encircling the conductor will give the direction of the magnetic field lines. Okay, these are the two things. They're very useful to find out the direction of the magnetic field. So now next one we'll go to what is magnetic field. So magnetic field is that the space or region around the current carrying conductor within which its influence can be felt by the magnetic needle is called the magnetic field of the current carrying conductor. So that means if it is a current carrying conductor, around this the magnetic field will be produced in this way, Okay, so if you go far away, the field will be also decreased, also become weak. So now if I bring a compass like this way, this needle, north pole, south pole, so if it is failed deflection, then you can say that the magnetic field will be there. The influence of the magnetic field is there if it is felt by the needle. So that is known as the magnetic field. Now, magnetic field is a vector quantity. I know already I told you magnetic field is a vector quantity. Magnetic field is a vector. And it will be denoted as B vector this way. Now next one will go to the magnetic force. What is magnetic force? So consider this is a plain sheet of paper. So consider a charged particle. Say the charged particle, the charge is Q, plus Q charge is there, and there is a magnetic field in this paper. The magnetic field is working in this direction, like this way, in this direction. Now the charged particle is moving in this direction. The velocity of the charged particle is v vector. If the angle between the velocity of the charged particle and the magnetic field is theta, then the charged particle will experience force along with the perpendicular, like this way, in this plain sheet of paper. I cannot draw the perpendicular lines or vertical three-dimensional line in the plain paper, so this is the direction. This is known as the Fm vector. Normally it will be a perpendicular like this, three-dimensional. Okay, so how to find out what is the, then what you can say, that consider a charge q is moving with a velocity v in a magnetic field B such that the v makes angle theta with the B, then the charged particle will experience a force. This charged particle will experience a force. Then how we can write down the force? What is the formula of the force? Fm is a vector quantity, force is a vector quantity, q v cross B. So now this is the cross product. So you can normally you can write in this way: Fm is equal to q, or you can write q vb bv sine theta. That you can write. How to determine the directions? So what is the procedure to find out the directions using the right hand? Again, right hand rule you have to use. So in this case, v is first and then b has came next. So you have to hold the b, hold the v along with the b in such a way that you are holding in a small angle. You don't use this big angle, in a small angle. So I'll put my right hand here. So I'm going to hold the v after that b. So in that time my finger is working in an upward direction. So what I told you, the force will be experienced in the upward direction in this way. Okay. Also you can write the force as it is working in the upward direction. Also you can write in this way. So this is v and this one is b. This is theta. So force will be in a dot like this. It's coming out from the paper. So now there are some special cases. I'll write. So what are the special cases? First one is if the charged particle is moving parallel or moves parallel or anti-parallel to the direction of the magnetic field B, and then that will happen. Then if theta, that means parallel means 90 degree, parallel means 0 degree, or anti-parallel means the theta will be 180 degree. Okay, the two things can be happen. Then sine 90, sine 0 is equal to sine 180 degree is equal to 0. Okay, so as sine 0, then force will be 0. So Fm will become 0. That means the charged particle will not experience any force. That means if the charged particle is not going this, the charged particle is going along with this direction, like along with the magnetic field, it will not experience any force, or going in this direction, in the anti-parallel direction to the magnetic field, so it will not experience any kind of force. Next one is if the theta is 90 degree, then sine 90 is what? Sine 90 is 1. So you can get Fm is equal to QVB. This is the maximum force will be experienced by the charged particle. Okay, and third point is theta is equal to 270 degree. So if 270 degree, then sine 270 is minus 1. So Fm will be minus QVB. Okay. So in the negative direction. And the fourth point is, if the charged particle is at rest, the magnetic field is there is no velocity, charged particle is sitting over here, standing over here, or rest condition. So if the rest means V will be equal to 0. So if V is equal to 0 means charge is at rest. Charged particle at rest. So what will happen? Formula Fm is equal to V is 0. So it means the entire thing will become 0. So 0. That means the charged particle which is not at all moving or rest will not experience any force by the magnetic field. So this is the things. So today is up to this one. So next class we will continue with the SI unit of the magnetic field and what is the definition of the magnetic field with this formula, and also we'll discuss about the relations between the magnetic field, the properties between the magnetic field lines and the electric fields. Okay, so thank you very much.